In Lesson 6D, arrays were introduced in the lesson on using the string split technique. In this lesson, those introductory concepts will be reviewed, and a more in-depth look at arrays will be provided. Also introduced will be a special loop, especially devised for array processing, called the for-each loop. What is an array? Arrays are the first venture into the world of data structures, able to manage multiple items of data. There are numerous other useful data structures available to use: array lists, linked lists, trees, maps, hash tables, etc. But this is a good place to start. An array is a fixed-size data structure, which can hold multiple items of the same data type. There can be arrays of integers, doubles, booleans, strings, characters, objects, even other arrays, two-dimensional and three-dimensional. As was mentioned in Lesson 6D, an array is like a bus, able to carry many passengers, compared to a single-value variable, like a bicycle with only one rider. An array must contain data all of the same type, and requires special handling techniques using index values and loops. Let's look at an array of integers. Below is a program that creates and gives beginning values to an array, a one-statement process called initializing an array. Note the data type, int, followed by empty square brackets, then the identifier, nums, the assignment operator, the equal symbol, followed by several values inside braces, separated by commas. The compiler counts the number of data items inside the braces, creates just enough memory space for those items, and references the memory location with the identifier nums, an object reference variable. Once the memory space is created, it cannot change in size. It is locked in, fixed in size. Although its contents can be altered, it cannot shrink or grow in size. To process the elements of the array, you must use index values to indicate which elements of the array you want to use, much like house numbers on a street. This process is called indexing. The output statements below individually and directly access each data item using index values, always integers. This can also be done using a loop, as we discovered in Lesson 6D, again demonstrated below. The for loop starts at 0, always the first index value of an array, and proceeds to length minus 1, always the last value in the array. It continues as long as the x value, which takes a single step after each output, is less than the length of the array. A new loop structure, specifically for processing arrays, is shown below. It is called a for-each loop, fairly new to the Java language. It is useful when all you need to do is retrieve the values for output or for other similar processing. It can also be used for other collection-type data structures in Java, like array lists, linked lists, etc. This process does not use indexing, but instead uses a special technique designed for quick and easy access. Let's take a closer look. Again, this is not a typical four-part loop. It functions specifically like the loop previously shown. Starts at the beginning of the array, traverses to the end, one memory location at a time, retrieving a copy of each element. This is all it can do. Forward from beginning to end, one step at a time. It cannot go in reverse order, two steps at a time, or any other way. It cannot change the values of the array since it does not use indexing. It is only for forward access, retrieval only, full traversal, one step at a time. That's it. Here's how it works. The variable x is not a loop control variable, but instead a single memory variable that matches the type of data contained in the array. It is followed by a colon, then by the array identifier. Important note, this variable can be any identifier you want. It does not have to be x. As the process proceeds through each element of the array, a copy of each data element is placed into the variable x, which behaves like a formal parameter that receives data from an actual parameter. The variable x first receives the value 3, then the values 5, 2, 7, and 5. Again, x is not a loop control variable. Let's summarize the key differences between these two loop styles regarding array processing. The for each loop does not use indexing. The for loop does. The for each loop always goes from start to finish. The for loop is more flexible. The for each loop cannot go in reverse. The for loop can. The for each loop can only go one step at a time. The for loop can take larger steps. The for each loop cannot change array values. The for loop can. The variable used in a for each loop is just a container that must match the data type of the array, not a loop control variable, as in a for loop that must be an integer. Here is an array of doubles, initialized in the same way as the previous example, and output the same 3 ways. Study it carefully. Notice the for each loop, especially the data type designated for it. It is a double, which matches the type of data in the array. In the normal for loop, x is still an integer, since it serves as a loop control variable. Here's an array of characters, also processed in the same way. Again, notice the for each loop variable, it is a char now. An array of booleans is sometimes useful, and it is processed in the same way. For your information, the word flag is often used to identify Boolean values in computer science program design, with the idea that if the flag is in the up position, it means true, and down meaning false, an effective visual way of expressing true and false values. Strings, as well as any objects, also work in arrays, and again, the processing techniques are the same.